Hey class, sorry I can't be there today, but you'll be okay without me, won't you? You thought you were going to get to watch a movie? You were sadly mistaken. We are going to learn a lesson with or without me. Looks like I'm really here, just through the computer. Creepy? Maybe, maybe not. That's me with Woody. Toy Story, by the way. If you guys get out some paper, we can take out some notes. Section 9.4, special right triangles. I'm trying to give you guys time to take out some paper. Didn't mean to startle some of you. First up, we have our two types of special right triangles. We have a 45 degree, and a 90-degree triangle. All triangles are special in my heart, but this one is special in other reasons. Again, we're talking about right triangles here. And this guy will be a 45 here, another 45 degree there. And we already know where the hypotenuse is located, and that's going to be opposite of the right angle. And the other two sides are the legs. Now, there are two angles that are exactly the same, hence being now congruent. If we have two angles that are congruent, then we'll have two legs congruent. So not only is this a special triangle that's 45, 45, 90, but this is also known as, aka, an isosceles right triangle. And this is the triangle we're going to be dealing with most today. Actually, this is the only triangle we're going to be dealing with today. We won't have to worry about this 30, 60, 90 here today. So, sorry about that. Don't worry about that guy. I'm going to try to give you guys a little bit of time to finish writing this. Make sure you guys have all this written down. All right. I'm going to go ahead and move on. Jump into what is so special about this right triangle. This was in your postulate worksheet. It's a 45, 45, 90 triangle theorem. I would also like you to write this in your notes. Okay, it is theorem 9.8, so you can refer back to there. I'm going to talk a little bit about it. Again, this triangle is a right triangle of 45 degrees here and 45 degrees in the other, third angle. We've already talked about where the hypotenuse is located. And the two legs. Now with these two legs, they're going to be exactly the same, hence the isosceles part. We're going to represent them with an X. We'll change the color on that.
William Gettinger, report to the art room. William Gettinger, please report to the art room.
Sorry about that. You know, those announcements. The other leg will also be considered x. They'll have the same measure. The hypotenuse is going to be a tad bit bigger, as it usually is. And in this case, in this special right triangle, it's going to be a certain amount bigger every time, all the time. It's going to be whatever a leg is times the square root of 2. Always and forever. So, you can say otherwise, the hypotenuse is square root 2 times bigger than either leg. And this is what we're going to concentrate on. Give you a moment to finish that up. All right, we're going to go ahead and move on. We're going to jump into an example. Are you with me? I really don't know if you are or not. Can't see you, so I'm guessing you are. Here we go. First example. Make it a little bigger for you. Find the missing measures. Write all radicals in simplest form. That means no decimals. Our first triangle here is indeed a 45, 45, 90 degree triangle with a side measure of 5 and a side measure of b. That b is what we're going to find. There are 4 steps of math that you will always need to take, whether you know it or not. The first step, what do you need? Good question. Always ask yourself, what do you need? Second step is, what do you have? Third step, to set up an equation or equations. And your fourth and final step is to solve. So take a minute, list these steps. What do you need? What do you have? Set up an equation, and we can go slowly get through this. So we're going to go ahead and try to figure out all these steps with this certain problem. Pick one off here. First step. I'm going to slowly scroll this down a little bit. I apologize. You'll be all right. First step. What do you need? You need this b here. Okay? Now talk to me. What is b? in this triangle? Is it a leg or is it a hypotenuse? You are correct there in front. It is a leg. And what is a leg equal to in this triangle? X or x squared root 2? And that would be x. Second part. What do we have? We have a 5, which is also a leg. Sorry.
Cody Hill, please come to the main office. Cody Hill, come to the main office.
Man, those announcements get me every time. Which is also a leg, like I was saying, which is also equal to x. And our third part is to set up an equation now. Well, let's think here. We know b is equal to x, and 5 is equal to x. So the fourth step comes pretty simple then. If b is equal to x and 5 equals x, then our b is what we need, must equal 5. I'm sorry, b equals 5. Not too bad for the first example, huh? All right, we're moving on. Example dos. Hopefully you guys have that here. Let me try to finish writing that up if you do not. I can be paused anytime. I'm going to go ahead and scroll down a little bit for our next example. Example 2. And I've already set up our 4 steps that we need to figure this out. Send the page a little bit. Sorry, you're okay. Don't worry about it. Now you notice that I've only written 1 degree measure here and this 90 degree. Okay, but you have to realize 90 plus 45 is 135. The rest of 180 will make up this angle here, which is also 45. You might see that, but you have to realize that's okay. Be safe. They just want you to know that the other angle will be 45 if these two are 45 and 90. Okay, first thing up. What do we need? We need C. C is your hypotenuse. It is opposite of your right angle, hence hypotenuse. We know a hypotenuse is equal to x, whatever x might be, times the square root 2. Second step is asking us, what do we have? And we have a nice little 6 here. And 6 is equal to a leg, which we know equals just plain x. That's what this special triangle is based off of, the legs. With this, we'll go ahead and set up a couple equations. We know C actually equals x square root 2, and 6 equals x. And then our fourth step is to solve. And we need to find the C here. With that, we know it equals x square root 2, and we know our x is going to be 6. So with that, we know our C is just going to simply equal 6 square root 2. Again, all I took was this 6 here, which equals x, and plugged it in for x. which gave us our c equals 6 square root 2. Our answer. Nothing else to simplify. It's 6 square root 2. Can't simplify square root 2, so it stays the same. Hopefully you guys all kept up with that. I don't know if I'm going too slow or not, but oh well. We'll go ahead and move on to our third example here. Almost there. Maybe go ahead and finish step 1 and step 2 for me. And we'll check our steps here in a second. Alrighty. So let's check here. Step 1. So what do we need again? Okay, we need A. Hopefully by now, A we can tell is next to the right angle. It's attached to it, which is a leg, which equals X. We have 16, which is opposite of the right angle, which is known as the hypotenuse, which equals X square root 2. To set up an equation, we have A equaling X and 16 equaling X square root 2. Now, we want X, we want our A here, but it equals X. Our X is over here. We're going to have to solve for X. To get our A. I'm going to scroll down a little bit so we have a little bit more room. Take this 16 equals X square root 2. And now it's just algebra from here. What's happening to the X? It's being times by square root 2. And we're going to do the opposite of times, which is divide by square root 2. Square root 2 on the right side, divide by square root 2 becomes 1. You're left with just X, which equals 16 over square root 2. You think, oh, it can't be that easy. Well, you're right. It's not. You know what I don't like, and a lot of other people? We don't like our radicals on bottom. So, keep a note. No radicals. That's this guy. On, I should say actually, in denominator. But don't worry, it's not that many steps to get rid of it. To get rid of the radical on bottom, we're going to go ahead and multiply the top and the bottom by the denominator, which is square root 2. So again, we multiply top and bottom by denominator. again, multiply top and bottom by denominator to get rid of a radical in denominator. Now we're going back to the problem where I multiplied top and bottom by square root of 2. That just simply on top becomes 16 square root of 2, which also means 16 times square root of 2. And on bottom, what is the square root of 2 times square root of 2? It's like saying, off to the side, 2 times 2 inside here, which is the square root of 4. Scroll a little bit down. Apologize, mess you up. $16 square root of 2 on top, we can't do anything with. Square root of 4 on the bottom, though, we know what that is. That's going to be a 2. We're almost done simplifying this. We have 16 square root of 2 over 2. A 16 and the 2 are both even numbers, which means they're both divisible by 2. And in this case, 16 over 2 is just simply 8. Don't forget my square root of 2, though. Okay? So again, we know that 2 went into 16 8 times, and 2 went to 2 once. So x equals 8 square root of 2, which then we were all trying to find this x to find our a. And our a equals x in this case, which is 8 square root of 2. Give you a moment to finish that, and then I'll show you the easy way of doing it. Oh. All right, now for the easy way. You guys don't hate me. Good thing I'm not there for you guys to throw things at me. So. Easy way. What you have to realize is that a leg is always half the hypotenuse times square root 2. The leg is going to be always half the hypotenuse times square root 2. For instance, if I give you a hypotenuse that equals 20, the leg is going to be half this 20, which is 10, times the square root 2, which is 10 square root 2. That is the measurement of your leg. x. Are you mad? I'm sorry. We're going to move on. I got one more for you. You guys are going to work on this one for yourself. I'll put the answer up here in a bit. Here it is coming up. Your turn. Example 4, last one. Again, you have a 45, 45, 90-degree triangle with a leg measurement and a, which is a leg, and a C, which is a hypotenuse to find. Make it happen. I'm going to slowly start putting the steps in here so you guys can make sure you're correct. So we've come down to step 1. I'm looking here. Step 1, where we have A, which is a leg, which is equal to x. We have C, which is a hypotenuse, which is equal to x squared root 2. And then we have the step 2, which is what do we have, which is 9 squared root 2, which we know is a leg, which is equal to x as well. Well, we can set up our equations. We know A equals x, and we know C equals x squared root 2, and 9 squared root 2 equals x. So A is going to be pretty easy to find. A will be whatever x is, and x is 9 squared root 2. Halfway done, what did you say? Now the C part here equals x squared root 2. All right? So all we have to do now is plug in this 9 squared root 2 in for x. C equals 9 square root 2 square root 2. It's like we did before. We know what square root 2 times square root 2 is. It's square root of 4. C equals 9 square root of 4. And we know the square root of 4 is actually 2. So C equals 9 times 2, which is actually a nice 18. And there we have it. Make sure you guys have all that written down. Hope you guys had fun with me. I had a blast with you. It was actually pretty easy without you guys in here. Yes, I'm kind of doing this by myself, so it kind of gets weird. But, oh well, it's for a good cause. Your homework will include 9.4 study guide worksheet. all dealing with the 45, 45, 90-degree triangles. They'll give you a side measurement, and you'll have to find the other side measurement using any of one of these 4 examples that I showed you. Use those 4 steps. And good luck to you. I will see you next week. Goodbye.